So let's review exponents. We have 6 to the third power, 2 to the third power, and we should also have something to the second power squared. So I'm going to add 4 to the second power. So in each of these, what is the base? Well, in 6 to the third power, the 6 is the base. In 2 to the third power, or 2 cubed, 2 would be the base. And in 4 squared, 4 would be the base. That's the number you're going to multiply over and over. What is the exponent? The exponent in 6 cubed is a 3. The exponent in 2 to the third power is 3. And the exponent in 4 squared is 2. That's how many times you would multiply it out. Write an expression that would be equivalent to 6 to the third power. So that would be 6 times 6 times 6. If I was going to write one for 2 to the third power, that'd be 2 times 2 times 2, the base 3 times. And if I was going to write one for 4 to the second power, that would be 4 times 4. So that's my expression. An expression does not have an equal sign. It does not have a greater than or less than sign. And my last question here is write in standard notation, evaluate, solve is equal to. I put all these different words because a question could say write, say, 6 to the third power in standard notation, or it could say evaluate 6 to the third power, or solve 6 to the third power, or what is 6 to the third power equal to. All of those mean to write them in standard form or to solve them. So 6 to the third power would be 6 times 6 times 6. 6 times 6 is 36 times 6. And 36 times 6, see, is 3 to 18, 21. So if I was going to write 6 to the third power in standard notation, that would be 216. If I wanted to write 2 to the third power, if I had to evaluate it or solve it, then that would be 2 times 2 times 2. And 2 times 2 is 4, and times 2 is 8. And the last one, if I wanted to find out what 4 squared is equal to, that would be equal to 4 times 4, and that's equal to 16. So the 16 would be my standard notation. Write 15 times 15 times 15 times 15 times 15 in exponential notation. Remember, exponential notation is when you are repeatedly multiplying over and over. So my base is going to be the 15. That's the number I'm using. Then I need to go through and count. I've got 1, 2, 3, 4, 5. So my exponent will be 5. So when I go to write this, writing that in exponential notation, it's 15 to the 5th power. Here's a quick review of adding and subtracting with whole numbers. So A is adding. The first thing I'm going to do to solve this is I am going to write it vertically. Now I have to make sure I'm going to put my comma here to help me line up. So my 8 goes in the ones, my 6 goes in the tens, my 5 goes in the hundreds, and my 1 goes in the thousands. I'll simply add that together. 9 plus 8 is 17. That's a 7, and I have to carry 1. 6 plus 2 plus 1, so 6 plus 2 is 8, plus 1 is 9. And I don't have to carry over any. I don't have to regroup. 5 plus 3 is 8. 7 plus 1 is 8. 4 plus nothing is 4. And there's my comma. So my answer is 48,897. Now, this next one for B, same numbers, but we're subtracting, so that is going to look a little different. I'm still going to line my numbers up, but now I'm subtracting. So 9 take away 8 is 1. 2 take away 6 I need help from the neighbor, so I'm going to cross out the 300s and make that 200s and make my 2 10s 12 10s. So basically I took away 100 and exchanged it for 10 more 10s, which is the same as 100. So now I've got 12 take away 6 is 6. 2 take away 5, oh, I need to borrow again. So I'm going to regroup. I'm going to take away one of the thousands and add on 10 100s. So my 2 becomes a 12 hundreds now. So 12 take away 7 is 5. 5 take away 1, I'm sorry, 6 take away 1 is 5. And then 4 take away nothing. And then my last one. Okay. Again, this is subtraction. Always double check those signs. It's really disappointing if you do a lot of work and then you added when you were supposed to subtract or vice versa. So this is subtraction, so I'm going to subtract over here. Okay. 0 take away 4. Okay, I want to borrow from my 4 in the tens place, make that 3 10s, and make this 10 1s. 10 take away 4 is 6. Now 3 10s take away 4 10s. I'm going to borrow from the hundreds. So I'm going to take 100 away and make the 5 a 4, and then add 10 10s over here. I traded them, not added them. So 13 take away 7 is 6. 4 take away 0 is 4. Go over to my thousands place. 7 take away 6 is 1, and 8 take away nothing is 8. Now we're going to review multiplication. 4,560 times 4. Start in the ones place. 4 times 0 is 0. 4 times 6 is 24, so we write the 4 and carry the 2 to the next place, or trade it over. 4 times 5 is 20, plus 2 is 22. 4 times 4 is 16, plus 2 is 18. So our answer is 18,240. Now we're going to multiply by 2 digits. So again, we start in the ones place. 2 times 9 is 18. Carry the 1. 2 times 2 plus 1 is 3. 2 times 8 is 16. And 2 times 4 is 14, plus 1 more is 15. Now, in 4th grade, you learned X's and O's, where you X out the number you just finished and you write an O down here. You're really putting a 0 in the tens in the ones spot as a placeholder, because we're not going to be multiplying by 3 here, we're actually multiplying by 30. So instead of doing 30 times 9 and 30 times 1 and 30 times 8 and 30 times 7, we already put 0 in the one spot, moving us over that spot. So now back to multiplying. So now we have to do 3 times 9. Don't forget to go back to the 9 and multiply. Don't start with 3 times 1. Don't forget that last ones digit. 3 times 9 is 27. Carry it 2. 3 times 1 is 3, plus 2 is 5. 3 times 8 is 24. Carry a 2. 3 times 7 is 21, plus 2 is 23. Now we're going to add these together. And the big problem I see kids have with these is they may multiply all the numbers outright, but when they write these down, their partial products down, they don't do them neatly and line everything up. Then they have a difficult time adding up and finding out what goes with what. See how I kept this all lined up here? So you might need to work on that, on your neatness. Even on the iPad where it's difficult to write, I could still write them and be able to read my own writing and line all the numbers up to make it easier to add. So now let's do multiply by 3. Okay, so now we're going to multiply by 3 digits. So again, we start in the ones place. 1 times 4 is 4, 1 times 6, 1 times 3, and 1 times 2. Okay, X out my 1, X's and O's. Now, as I'm actually multiplying by 50, so my 0 is already there. So 5 times 4, don't forget about multiplying over by the ones place. 5 times 4 is 20, 0 carry a 2. 5 times 6 is 30, plus 2 is 32, carry a 3. 5 times 3 is 15, 18, carry a 1, and 5 times 2 is 10, plus 1 is 11. So now I'm going to cross out the 5, and I have 2 X's, so I need 2 O's. I need 2 placeholders because now I'm multiplying by 200, and 200 has 2 zeros in it, 2 placeholders. 2 times 4 is 8. 2 times 6 is 4. 2 times 6 is 12. Remember, 12. 2 times 3 is 6, plus 1 is 7. And 2 times 2 is 4. So I'm going to add these all together. I slid this up to give myself a little more room. I was careful when I wrote down my partial products to make sure everything lined up. So now I have to do 3 plus 2 plus 8, which is 13. All right, and 1 plus 2 plus 8 plus 2, so 8 plus 2 is 10, plus 2 more is 12, 13, carry a 1, 7, 8, 9, and then 5. So my product is 593,364. So now we're going to multiply with fractions. So what is 5/6 times 3/7? So you multiply numerator by numerator. So 5 times 3 equals 15. And denominator by denominator, 6 times 7 is 42. Now we're going to simplify our answers. Let's see. The factors of 15 are 1 and 15. Neither of those, well, 15 doesn't go into 42. 3 and 5. 5 doesn't go in, but 3 does. So now I'm going to simplify by dividing by 3 over 3, which is the same as dividing by 1. So 15 divided by 3 is 5, and 42 divided by 3, let's see, I'm going to do a little bit of math here. 4 divided goes 1 time, 14 times I can see. Okay, so the answer to this one would be 5/14. Now you might have noticed that we could have simplified before we multiplied. So because you can simplify a numerator and denominator before you multiply, and the 3 and the 6 both have 3 as a common factor. So I could have divided by 3 before I multiplied, and that would have given me a 1 here, and that would give me 6 divided by 3 is 2. So now I'm multiplying 5 times the 1, which gives me 5, and the 2 times the 7, which gives me 14. So either way, I end up with 5/14. What is the product of 8 times 2/9? So that's another way to ask to multiply, is by using the word product, because the answer to multiplication is product. So this is very similar to the top, except there's a whole number. So we like to put that whole number under 1, over a 1. So I get 8 firsts, which is the same as 8. I'm just renaming it. I'm just writing it a different way, but it's still equivalent to, it's still the same as. So now I just multiply 8 times 2 is 16, and 1 times 9 is 9. Now there is no simplifying before I multiply here, because there aren't common factors between the numerator and denominator. 2 and 8 have a common factor, but they're both numerators, so you can't do that. It would change the value. Now I have 16/9. I need to change this back into a mixed number. So I'm going to do 16 divided by 9. So there's 1 9 and 16. I subtract, there's 7 left over. So the 1 is my whole number. So that's a 1. and then 7 is my numerator, and my divisor, my 9, is my denominator. So my final answer is 1 7/9. What is the product of 5 1/6 and 7 3/4? So now we're multiplying mixed numbers. Before I can multiply mixed numbers, I need to turn them into improper fractions. So I'm going to do 5 times 6 is 30 plus the 1 up here, so I get 31 and keep the denominator of 6. So 5 1/6 is equal to 31/6 times 7 times 4 is 28 plus the 3 is 31/4. So when I multiplied out 31 times 31, I got 961, and 6 times 4 is 24. Now I need to turn this back into a mixed number again. So I need to do 961, my dividend, divided by 24, my divisor. So 24 into 96, let me think. I know 25 times 4 is 100, and 96 is close to 100, and 24 is a little less, so I'm going to try 4. So I'm going to try on this side to see. 4 times 4 is 16, 4 times 2 is 8, 9, 96. Oh, it's it exactly. So I know that 24 does not go into 9, but it does go into 96 4 times, and 4 times 24 is 96. Subtract, I have a 0, bring down my 1. 24 goes into 1 0 times. So 0 times 24 is 0. I have a 1 as a remainder. So 40 is my whole number, and my 1 is my numerator, and my 24 is my denominator. So I have 40 and 1/24. Mr. Sabo is building a deck. He needs 4 boards that are each 1 1/6 inches long to build steps. How long of a board does he need to start with so he has enough? I did not write inches in there, but I had meant to type inches in there. Okay, so let's see, he needs 4, and each of them are 1 1/16. So we need 4 times the 1 1/16, 1 1/6, I'm sorry. You could just add the 1 1/6 4 times over, but it's repeated addition, so we can use multiplication. So again, this is the 4 we turn into a mixed number into an improper fraction by putting it over 1, because 4 firsts is the same as 4. And we will change the 1 1/6 by doing 1 times 6 is 6 plus 1 is 7, and putting that over your 6 as your denominator. So now we can multiply out. Okay, 4 times 7 is 28, and 1 times 6 is 6. Let's see, I could simplify here before I divide this out. Oh, I could have simplified before I multiplied. I'll go back and do that to show you that also. So I'm going to do 28 divided by 6 to change it back into a mixed number. So 6 goes into 28 4 times. Subtract, and I got 4 left over. So 4 is my whole number. My remainder is my numerator, and my 6 is my denominator. And I can simplify that even further to 4 2/3. So he needs a board that's 4 2/3 inches long, so he can cut them into 1 1/6 inch pieces for his steps. Let's see, this would have made more sense if I would have done feet instead of inches. Now, what if I simplified before I multiplied, though? So if I had gone from this step right here and realized, oh, hey, look at the 4 and the 6 have a common factor of 2. So I divide this by 2, I divide this by 2. So 2 times 7 is 14. And 1 times 3 is 3. Now I still have to do 14 divided by 3, so that goes in there 4 times. I got a 2 left over. So again, that's a 4 and then 2/3 inches as my final answer. Mrs. Young is baking cookies for a treat. She's going to make 2 1/2 batches, so there's enough for everyone. The recipe needs 1/3 cup oil for each batch. How many cups of oil does she need to be able to make enough cookies? Well, one way, let's see, I'm going to do repeated multiplication because I need 1/3 cup 2 1/2 times. So I am going to do 2, oops, let's try that again. I need 2 1/2 times my 1/3 cup of oil to figure out how much oil I have to see if I can make these cookies. So I'm going to change the mixed number into an improper fraction. So I do 2 times 2, which is 4, plus the 1, which gives me 5/2 times 1/3. Numerator times numerator, 5 times 1 is 5, and 2 times 3 is 6. So I actually need 5/6 cups of oil to make 2 1/2 batches of cookies.